I am super pleased today to introduce our guest speaker, Patrick Schmitz. I've been, and I know many of you here in the room and joining us remotely, have been aware of Patrick's work for some time and the impact that it's had on some of our operations here at the University of, well, not here, well, kind of here, as in BC, but at the University of British Columbia, we do leverage some of the outputs of Patrick's work, which you'll hear about here a bit later today. So a few words on Patrick. Patrick Schmitz is the founder and principal consultant at Semper Cogito, providing strategic technology consulting and academic research IT. Schmitz is an active contributor to a number of CaRCC, that's the Campus Research Computing Consortium, for those of you who aren't aware. Their working groups he co-chairs the Research Computing and Data Capabilities Model and RCD Career Arcs Working Groups and is co-PI for the RCD Nexus and NSF CI Center of Excellence pilot. Prior to this, he spent 12 years at UC Berkeley as an Associate Director of Research IT for Architecture and Strategy, providing IT strategy and solutions in support of campus research and Director of Berkeley Research Computing. In addition to his experience in academia, he was a researcher at Microsoft Research, Yahoo Research, and CWI in Amsterdam, and co-founded a series of tech startups. Please join me in welcoming Patrick. Over to you, sir.
Thanks very much, Matt. I appreciate that warm introduction. I'm going to go ahead and share my screen to get my slides up. Everybody can see those now. Great. So, hi, everybody. I want to thank the DRI Connect organizers for inviting me to share our work with you today. I appreciate the land acknowledgements being shared in the program, and I happily and respectfully acknowledge that I live and work on the territory of Huichin, the Chochenyo-speaking Ohlone people, successors of the sovereign Verona Band of Alameda County. But I've been deeply frustrated that in our zeal to add more housing, the city of Berkeley recently decided to ignore the deep cultural significance of the West Berkeley Shell Mound site and has pushed through a permitting process to build housing and parking on the sacred Shell Mound site, which makes our local land acknowledgements feel a little hollow. So I hope we can do better with that. I know a few of the folks here today, but for everybody else, as mentioned, I consult on research IT assessment and strategy for higher ed, co-chair a number of working groups around some of this work. I studied computer science, linguistics, and art, and after a string of startups and research positions, I returned to UC Berkeley for graduate studies to do some natural language processing work on museum collections, and that led to a job at the university leading the research IT group. We did a lot of work on museum informatics and infrastructure for digital humanities research and developed the research computing and research data management programs there. These days, I focus on the work I'll be talking about today, as well as support for research planning at historically Black colleges and universities and tribal colleges and universities. Now, before I get started, I want to do a quick aside. I really enjoyed the keynote yesterday by Dr. Laura Still, and I wanted to provide some tongue-in-cheek advice to all of you who run research computing programs. This is from a lightning talk I did a few years ago. So we all know high-performance computing was created for physicists, and many folks really want to keep it that way. So here's some tips on including these newcomers. If you're trying to keep out social science and humanities researchers, I would note some important principles. Assume their needs are basically the same as the science. Maybe just suggest data and computing light. Focus on hardware and not consulting. People are expensive anyway, so this will also save you some money. Use HPC experts and programmers to support these new domains. I mean, they can't be as hard as the physical sciences, so it should be fine, right? And there's no need to go out and invite them in. Just wait till they come to you. Next, expect they'll do their training on their own. That's what real science PhDs had to do, right? And then focus on faculty over pesky graduate students, especially in the humanities. That way you can say you're helping, but avoid the folks who do the real work and the researchers who are trying these new computational methods. Sadly, when I was at Berkeley, we did not follow this advice closely, and we failed. We led Project Bamboo, which investigated cyber infrastructure needed to support the arts and humanities, and we partnered with a number of campus groups on DH projects. Somebody even got the bright idea to develop a Jupyter notebook that allowed Egyptologists to easily run photogrammetry jobs in our GPU pool. which meant that the work that had taken 3 weeks on their laptops now only took 15 minutes in the cluster. Those researchers went and told all their friends, and you can imagine what that led to. Not having learned from that, we also worked with a number of campus orgs supporting social scientists. And rather than the tried and true approach of hiring only white men with PhDs in physical sciences, we hired a range of folks from all kinds of different domains. Then we got ourselves involved with students supporting hackathons that just exposed more of these new domains to our resources. From what I heard yesterday, the McMaster's Digital Research Commons pilot is set up to fail in the same way and will likely have a host of humanist and social science researchers using their resources. The hard lessons learned are that it takes very little to make these communities happy. And once in, you can't get rid of them. If you link up your computing and data support programs, it only gets worse. Strangely, the problems you solve for these new domains actually benefit your traditional users as well. The bottom line is that if you actually help people to use your services, almost anyone may show up and use them, so beware. Now, when I first gave this talk, some folks were laughing and others were cringing as they recognized that they were in fact following this advice. Small wonder that they supported a relatively small set of research domains. Fun and kidding aside, one of my passions is to ensure that we're committed to serving a broad and diverse set of researchers. And to be successful at that, our community of professionals must be broad and diverse as well. So I'm going to tell you a little bit about the CARC community that Matt mentioned that supports the work I'll be talking about today, and where I spend a lot of my time now that I'm theoretically retired from the university. So for those who've never heard of CARC, the Campus Research Computing Consortium is a community-led effort with leadership contributed by volunteers from a variety of institutions and organizations. A National Science Foundation grant, actually a series of them, have provided funding for some of the tools development as well as organizational and logistical support, more about which in a minute. There's so many people from across the community that contribute to CARC activities, and this is just a partial list. We also enjoy support from a wide range of institutions, including a growing set of Canadian universities. So a little history. CARC grew out of an NSF Research Collaboration Network grant in the summer of 2016. We started out as a coalition of the willing, about 12.5 universities interested in sharing knowledge, experience, and good practices. As more people and institutions got engaged, we evolved into an organization known less for who we are than for what we do and what we produce. Now, in my talk, you'll see me make a lot of references to RCD, which is intended as an inclusive moniker. It's an abbreviation of Research, Computing, and Data. And as we use it, this includes technology, services, and particularly people supporting the needs of researchers and research. And it's intended as a broad, inclusive term covering computing, data, networking, software, security, the whole shebang. The National Science Foundation is fond of the term cyber infrastructure, and others use research IT. They're all basically interchangeable. So CARC works to advance the frontiers of research by improving the effectiveness of RCD professionals and organizations, by promoting RCD career development and visibility, and by hosting community-owned and collaborative working and interest groups and their products, logistically supported by CARC's central infrastructure. That includes a logistics group, an operations group that focus on a variety of supporting the working operations, and an engagement group that's helping us to share out the work that we're doing. We have core principles around transparency and shared attribution and credit. The leadership team makes decisions with a rough consensus model, ensuring all voices are heard. And we're just one of a number of organizations in this space. We work to be a good community peer there. CARC is widely recognized as a community convener, a boundary spanner, and a provider of tools and resources, including by peer organizations such as the Research Data Access and Preservation, Coalition for Networked Information, Ithaca SNR, and happily, the Digital Research Alliance of Canada. The RCD Nexus is an NSF-funded CI Center of Excellence demo pilot that provides services to and supports many CARC efforts, from working group activities to workshops, like the upcoming RCD Nexus Day at the PERT conference, as well as more robust communications across all these activities. And as the graphic indicates, CARC includes a number of elements and activities. So the People Network is the heart and soul of CARC. It's a year-round online conference that aims to foster, build, and grow an inclusive community for campus CI professionals who support research computing and data resources and the researchers who use them. The network includes synchronous and asynchronous opportunities to leverage collective and individual expertise with focused discussion tracks reflective of professional activities, and it's open to anyone. These tracks mostly correspond to the facings taxonomy plus the emerging centers track, and I'll talk more in a minute about the facings for those who aren't familiar with it. It's just a way of organizing, describing the work that we do. Now, this graphic gives you some idea of how CaRC has grown over the past few years, from about 100 folks in late 2018 to over 2,100 call attendees in 2022. And for folks who can't join our calls, we post about 150 archive talks to our YouTube channel, and these have well over 2,000 views themselves. CaRC also hosts a number of working groups, which are just a group of people who come together to develop and publish tools and other resources. So the professionalization working group has been working on frameworks like a job family framework that HR groups and campuses can use when they try to come up with better ways of classifying the work, the folks that are doing this work. A career arcs group spun off from that to really look at where do people come from when they get into these roles, and how do they make decisions once they're in RCD roles? How do they think about their careers? And it's really designed to help us both to give better professional development opportunities and understanding to people, and to help with recruitment for managers who are trying to figure out where do they find these folks. The capabilities model I'll be talking more about is most of the talk. There's also a couple of interest groups. These are groups that come together but don't have specified deliverables. So a decadal survey group is working to develop a survey and report, kind of like what research domains have done for, say, astrophysics or the earth sciences. And then the staff and student workforce development interest groups supporting current and potential RCD professionals and curating leading practices for onboarding, training, and professional development. So now you know all about CaRC. Let's talk about the capabilities model. So it started out with Internet 2, which provides major network backbone and services for research and education. They seeded the ideas for what was originally termed a maturity model for research support, and got the discussions going back in about 2017. So CaRC facilitates the working group that developed the tools and supports the ongoing work here. We've also worked with EDUCAUSE and their research computing and data community group, and the team there that supports what's called a core data survey. They helped us to think about and share their expertise in this kind of data gathering. So to start with, let's consider some of the challenges faced by folks trying to develop and plan for their RCD support. The first, how do we get a comprehensive view of our support? How do we represent the state of our research computing and data services to our leadership and key stakeholders? And are we missing something? What else should we be paying attention to that we might not have thought of? As we think about strategic planning, funding, and hiring, how do we identify areas for improvement and growth? The model allows institutions to assess their support for computationally and data-intensive research. A structured model facilitates discussion among different groups, roles, and service providers. It helps you identify gaps. These gaps may already be on your radar, or they may be in areas you weren't thinking about. The model was developed by a diverse group of institutions with a range of support roles. In a collaboration, as I mentioned, among Internet 2, CaRC, and EDUCAUSE. The assessment tool is designed for use by a broad range of institutions. Now, the structured model shared across the community facilitates gathering a valuable data set for understanding broader trends, as well as patterns among subgroups, for example, emerging centers versus large research universities or minority serving institutions. We produced community data sets in 2020 and 2021, and the 2022 data set just came out with the analysis still pending. We developed a custom data set for the EPSCoR community, which are institutions in underfunded US states and jurisdictions, and I'll talk more about that in a bit. So it was designed, as I mentioned, for a range of stakeholders. This includes campus research computing and data practitioners, those on the front line, like us, like me anyway. Principal investigators and research team members, which is often faculty and staff or postdocs. Key partners, including your central IT groups, centers and institutes, and especially your libraries, as well as campus leadership. It was intended to be used across a range of institutions, and it has been used by both large research universities as well as small emerging programs. And later, I'll mention some of the work that's been informed by the experience of these smaller programs. So what is this tool? It's a structured means of assessing the state of your RCD support. So the first version was implemented as a spreadsheet, which you can see a screenshot of here, which enabled people to collaboratively complete it. It poses a series of questions for you to consider. So for example, do researchers have access to sufficient storage to support their data-intensive computing needs? Or do they have access to a high-performance network that supports research within campus? So there's a whole series of these. The answers yield a computed value, and where those answers are color-coded to provide a heat map view of your assessment, ranging from green to pretty good to red where you actually have gaps. And note that these, in general, the questions are phrased to emphasize support available to researchers and not how they're provided or who on campus provides the service. This isn't about an HPC group service catalog. This is really about what's available to researchers. It's also important to note that most institutions cannot realistically think about complete coverage across all of these topics. It's an aspirational model reflecting the union of all the things that the community thinks are important to consider in supporting research computing and data. In particular, it makes no sense to compare the coverage values to grades on an exam, where you're actually expected to know all the material. Median values are generally in the 50s and 60s, where that's a % of coverage across all these different topics. And there's a good deal of variation around that median and across the different topics. So as you can see here a little bit, the individual questions in each row are grouped into topic areas or themes. So like the ones up on the screenshot are storage infrastructure and network and data movement infrastructure. This is from a system-facing part of it. So we have these roll-ups into themes, which allows us to do more summary reporting. Now, the model divides areas of capabilities based upon a concept I call facings, which I mentioned, where there's one tab for each area. And I want to take a little bit of time because not everybody may have heard about the facings, and it's a really important concept we're using in a lot of areas. So the idea of facings was developed in a series of workshops that were exploring how to organize and talk about the people who support RCD. Researcher-facing roles include research computing and data staffing, outreach, and advanced support, as well as support in the management of the research lifecycle. And some of the example roles include research IT user support, facilitator, and CI engineers you see there. Data-facing roles range from data creation to data discovery and collection, data analysis and visualization, research data curation, storage, backup, transfer, preservation and transfer, and research data policy compliance. So here you get the RDM specialists, data librarians, and sometimes data scientists fall into this. Software-facing roles include software package management, research software development, like the research software engineer group that's worldwide now, research software optimization or troubleshooting, workflow engineering, and more recently, some new methods around containers and cloud computing, as well as securing access to software and software associated with physical specimens or research collections, for example. And these roles are the classic research software engineer, as well as research computing support. Now, the systems-facing roles are the ones that traditionally were best understood, although people are beginning to understand the other ones better now as well. But this includes infrastructure systems, systems operations, and system security and compliance. So these are, range from HPC systems engineer, storage engineers, and network specialists, and other such things. And last, we have the strategy and policy-facing roles, who are responsible for institutional alignment, the culture for research support, funding, of course, and partnerships and engagement with external communities. And this is typically lumped under research IT leadership. This facings taxonomy has been helpful in describing the various RCD roles and is getting traction across our community. It's important to note that at some smaller institutions, one person may have most or all of these roles. While in larger institutions, there may be entire teams associated with a role. The facings are not mutually exclusive, but they're meant to describe what a person spends much of their time in doing. So it's about roles and activities, not a person. In surveys that ask people which facings their work includes, people overwhelmingly check more than one box. For example, given my various roles across different projects, I check everything except systems facing. Okay, so with that, coming back to the tool, for each of the questions, we ask folks to consider several lenses. The first is shown here and has been called deployment at your institution, although we may tweak that in the next version to better reflect the intent, which is really how available a service is or a resource is to researchers across an institution. So the values range from having nothing there. We have no deployment or support to where, while we're tracking that, we're thinking about it, we're in the initial stages of planning piloting or initial deployment. But the most common thing for an established service is deployment to parts of the institution, or at the ideal, you actually have deployment institution-wide. And in order to be able to answer institution-wide employment, that also means equitable access to everybody. So if you have a service that is recharge-based and the funding is coming at the department level from research overhead, what that typically means is that the physical sciences who have big grants have it largely subsidized, and folks in social sciences and humanities don't have that level of funding, and it's very expensive for them. And you can't really say it's available institution-wide in an equitable manner if that's the funding model. Another important lens is called the service operating level. And this was inspired by ideas from IT service management. Here, what we're trying to get at is how robustly are you actually supporting the service? So there's who has availability of it in the one I just talked about, but here it's how robust is this, how sustainable is it? And again, it's, you might have nothing there, but if you've got a service that's just run by a couple of grad students, we'd have to characterize that as that substantial risk of failure. As soon as those folks leave, you may be in trouble. Lights on only is not uncommon for many services. People have a really basic funding level and they're keeping it going, but they can't really do anything except keep it going. A basic economy service is, you're there and you can occasionally handle special requests. Very few institutions can run many services at priority or premium level, which we characterize as being able to handle almost any new request that comes in, including requests for new support, special requests for classes and things like that. So that's an ideal. It's really hard to achieve that across many services unless you have substantial funding and institutional support. So in addition to assessing your current state, the team can also mark specific topic areas for attention. So I would note that you might have low coverage in an area and not make something a priority. Maybe that's just not where your research teams are going this year. And on the other hand, even with good coverage, you may want continued investment and development in an area. And so you make that a priority even on an ongoing basis. Now, these priorities were something that people asked us to add in early versions of the tool. They don't contribute in any way to the computed coverage values, and they're really just there for use by the team that's doing the assessment so that they can actually mark those things as they're using this as input into a strategic planning process. As folks complete the survey, then the summary sheet in that tool automatically rolls up the different areas into a view that you can use in discussions with your leadership, with your key stakeholders. A lot of people bring this back to an advisory group to show them this is where we stand. Sometimes they do a two-pass where they do the assessment and then they fill out the priorities. Anyway, there's even a bar graph here that you can grab for reports or presentations, again, in response to requests from the community. Each facing has a summary coverage value. That's just an average of all the topic areas. And then you can drill down one step. As seen here, we've expanded the software facing, and you can see the different topic areas there, again, with that sort of heat map view of something. So here, for example, in this hypothetical one, software package management and the software for physical specimens is in really good shape, whereas some of the others around software development, in particular workflow engineering, there's very little coverage. This is an area that, in this hypothetical example, they just haven't spent any time doing, and it's called out as a big red gap here. I mentioned the priorities feature that you could mark. The summary also gathers up the items that your team marked as a priority, again, just to make it easier to feed these ideas into your strategic planning work or to generate a quick report for your leadership. We've also started running some statistics in the community data set to look at what people in the community and what groups within the community are marking as priorities. So even though it's separate from the coverage values, we're seeing some interesting patterns out of that data as well. So after folks complete and submit their assessment, we produce a benchmarking report for them that shows where their coverage values land relative to the aggregated results from the other institutions. We gather all the results together. They're kept anonymous and they're only used in aggregated form, but it does allow us then to have this kind of benchmarking support. So in this example page, and this is again is run from an early report, and we're going to replace some of this stuff, and I'll talk about that in a sec. But what you see in the report is that in the white column running down on the left after the topics is the percent coverage for all these topics for this particular institution. And then what that means is a percentile ranking. So the next column over is for all data. So in this instance, their researcher-facing capabilities overall put them at the 58th percentile relative to the entire community, a little higher relative to public universities in the next column, a little lower relative to the privates, because privates tend to have more funding and do better on these things. The next three purple-headed columns are for Carnegie classifications, which is a US thing that ranks research institutions relative to their activity and allows people to say, okay, if I'm what's called an R1, one of the top research ones, I want to compare myself to other R1s, and you can see where the percentile ranks there. Not surprisingly, if you compare yourself to smaller institutions, your percentile rank jumps up. EPSCoR, as I mentioned, is a program for underfunded states, and that was a sub-community that wanted to be able to compare themselves within and relative to others, their peers, and then minority-serving institutions. Now, this is sort of a crude tool. It gives you some mechanism of slicing the data a little bit. What we really want to be able to do is let people go in and say, let me filter all the community to say, I want to look at big universities in the East, and or let me look at this set of universities that I know contributed to the assessment. And this new portal that we're developing is actually going to allow people to do that, where you have filters that you can say, let me filter on size, and let me filter on location, or let me filter on whether they're public or private, all these different things, and build a very customized report that instead of being this wall of numbers, lets you say, look, these are the folks I really want to compare against, and I want to show how we're doing and present that to my leadership so that I can make the case for greater support for our program, for example. So who's using it? Well, we've had about 270 downloads from over 150 unique institutions. And the reason we have more downloads is that some people do it multiple times. And so we've got multiple downloads from some of the same institutions. This actually represents all 50 US states, District of Columbia, several US territories, and 4 other countries, including 5 Canadian provinces. Sadly, this mapping tool does a really poor job of showing the Canadian provinces. I apologize for that. I tried to find a better one, but it had to jump to an entire North America map, which didn't look very good. We have a pretty good mix of Carnegie classifications, which again is sort of the size and rank of research programs. And we know that our mix represents roughly the demographics of all US institutions. It's again, a representative mix of public and private folks and EPSCoR institutions. We're making some progress with smaller and minority serving institutions, and we're working hard to increase representation there. When we ask folks, what do they want to do with this? Most institutions do say that they plan to use it as part of a strategic planning and benchmarking exercise. So they're going to take this and use it as input into a strategic planning discussions, or they want to be able to make the case, possibly for funding reasons, to show where they are relative to other institutions. However, quite a few also said that they found real value in just understanding what the broad community thinks about RCD support. And so especially some of the smaller research institutions that are still building up a research support program, they want to know, well, what is everybody else doing? And how do we know where we should be paying attention? Or even some of the things that we might aspire to, but we can't possibly think about now. They really liked having that sort of overall framework to discuss this stuff. So in addition to the benchmarking reports, the community data set allows us to better understand trends across the community. We published that first set in 2021 with 41 contributing institutions. We had a lot of interest in that full report. We did a paper at the PERC conference, which I hope many of you are familiar with. It's Practice and Experience in Advanced Research Computing. It happens every summer. Really should go if you don't know about it. And this summarized our findings. The scatter graph is one of the visualizations I like and nobody else does. And I laugh about that because you can't really interpret the data directly. And it's not about looking at the data points and understanding what they mean individually. It just becomes an eye test. rather look and see at how dispersed the pattern is. And that's really what I think is interesting about this. There's tremendous variance. Here, each vertical slice is an institution. And so there's 56 in the current data set, and each colored dot is one of the facings. The point is, coverage is literally all over the map. There are no obvious patterns here. There's a huge range in terms of people's coverage, and there's not obvious patterns in terms of everybody doing better at one facing or another, which I think is really interesting. And it's really helpful for us to understand our community better to have this kind of data. Interestingly to me, we're continuing to see a lot of repeats as institutions want to have longitudinal data. And right now, we published the data set for analysis. We're working on the in-depth reporting on that right now. This is another eye chart, but I just want to point out that there's a pretty good set of fairly well-known institutions, as well as some that you probably have never heard of. And so it's an interesting mix of people who've actually contributed here. We have a lot from Hawaii as part of a project we were doing there, and part of the EPSCoR work as well. So it's an interesting mix. So I mentioned we can learn some stuff from the data set. What are the things we're learning? This visualization compares topics in the researcher-facing area across institutions by their Carnegie classification, which again, basically measures the size of their research program. The dark blue here are the R1s, which are the top 130 research universities. And it's not surprising that they're well ahead of their peers that have smaller research programs. Although what's interesting is that there is reasonable parity when it comes to supporting the research lifecycle management, where they ask things like, are research supported across the full research lifecycle? And do they have access to advice on compliance, security management, and governance? This is a somewhat obvious result. You might say that big universities have better coverage, but having the data to back up our common sense of things really helps us to understand the experience of the whole community. You'll also see the gray error bars there. That's one standard deviation. And we include them just to emphasize that there's a lot of variation. It's not like there's a really clean pattern in all this. Even within these groups, you'll see that the highs in the small institutions are well above the lows in the biggest institutions in some areas. Now, the National Science Foundation, as I mentioned, has this program called EPSCoR. It's the established program to support competitive research, and it supports institutions in underfunded states and jurisdictions. That is, those states that get less than 0.75% of NSF funding. There's kind of a bimodal distribution in the US, where a lot of big states get lots of research and a whole bunch of smaller states get very little NSF funding. The EPSCoR program is designed to address that. Now, the EPSCoR community understands itself as a community. They meet regularly, and they wanted to develop a data-driven argument for investment in key infrastructure areas. And so they decided to use the capabilities model as the basis of a national workshop that would identify their common strengths, but in particular, their shared gaps and challenges. Among the biggest gaps relative to their non-EPSCoR peers are shown in this visualization of data-facing topics. Note in particular the significant gaps in the areas around data discovery and collection, data analysis, and data visualization. You know, the dark green are the EPSCoR states, the light green are their non-EPSCoR peers. And you can see they have like half the coverage levels in some cases. Now, these are areas of support that are critical to data-driven research, as well as the teaching of data science and data-intensive research methods. And the gap in infrastructure capability helps explain the gap in research capacity and funding. There's also a market gap in support for security around sensitive data. And without this kind of support capability, researchers have a much harder time working with controlled, sensitive, or licensed data. Now, in her keynote yesterday, Dr. Still talked about the gaps in data support for humanities research. And I would expand on that to note that many, if not most, universities are struggling to fully address RDM needs, and especially to support collaboration over sensitive or restricted data. And that doesn't just mean like health data. There's a lot of licensed archives, for example, that humanists are working on. And the ability to actually collaborate across those, which is a problem of both identity and access management, as well as technical infrastructure, they're really challenging. These are big problems for all universities, but you can see that the underfunded folks are way behind on this. I'll be really interested to follow the progress of the tri-agency research data management policy discussed yesterday and its impacts going forward. I'm hoping that you guys are on the lead and are going to help push some progress on this. In this visualization, comparing public and private institutions with respect to software-facing capabilities, we see that the private institutions are well ahead of the public peers in many areas, especially related to software development, optimization, and newer cloud support models. Again, this might not be surprising to you, but having the data is really important for a meaningful discussion, right? Because people can say, oh, the privates have more money. Well, okay, how does that translate on the ground to better support, or does it? And you'll see, for example, in some areas like securing access to software or software package management, there's not much difference. Whereas when it comes to actually having more people to do things like software development or optimization, the privates are doing much better. Now, we also can learn from some of the longitudinal data, and this is a filtered set looking just at the strategy and policy-facing topics, and just for institutions that have repeated assessments in 1 or 2 years. And I would mention that a number of institutions actually are repeating their assessments every 1 or 2 years to track their longitudinal process. It's really interesting. I was kind of surprised. I expected that people might do this maybe every 3 years to basically track a cycle of strategic planning. But some folks really want to see, okay, how are we making progress each year? And we see a fairly marked increase in coverage values for these topics over time. And this is only over the course of several years. Although I will note that the coverage slipped a little in a couple of areas related to funding and institutional culture. They grew quite a bit from 2020 to 2021 and then fell back a little bit. This may be partly because these are areas that have been strained by competing priorities during the pandemic. I'm not sure. But in our analysis, in particular for the EPSCoR National Workshop Report, we noted that for the 5 EPSCoR institutions that repeated assessments, the average strategy and policy-facing coverage rose from 44% to 60%, which is a remarkable 35% increase in a couple of years. Now, could this year-over-year progress be correlated to engagement with the Research Computing and Data Capabilities Model and to their use of it in their strategic planning practices? I'd love to think so. Perhaps these institutions had resolved to make improvements in this area, and so were motivated to use the capabilities model as part of that. And perhaps the exercise of conducting the assessment helped them to structure their strategy and policy-facing work. In any case, I think it's an intriguing pattern in the data. So, looking ahead, thanks to the NSF funding from the RCD Nexus, we're updating the tools, and this is something I'm really excited about. We're going to have a more robust implementation. We're almost ready to go to our alpha testing on this. Basically, it's an online tool that feels a lot more like a survey with a better user interface. It's going to have the same questions and model underneath, although we're refining some of the pros a little bit, adding a little bit more help text to explain some of these things. But the nicest thing about it is that it's fronting the database where we aggregate all the data, which means as soon as you've completed it, commit it, submit it to us for review, then we can produce a benchmarking report right away, and you don't have to wait till the end of the year when we run those reports. So it's just going to be a much better environment. It allows for better role management in terms of who can make commits and who can answer things and who can just view it. We're also going to replace those static reports that we generated for the first version with a data exploration portal. And this is going to allow folks to interactively explore the community data set. The public folks can get in at the summary level and look at this, but also we can generate those custom benchmarking reports or custom views of the data for folks that are contributors. Basically, if you're a member of the public, you'll be able to see just at that summary topic level, whereas people who contribute data will be able to drill down to the individual question level and say, okay, we marked these 5 things as priorities. We want to know exactly where we stand on those relative to our peers. That's the kind of thing that they'll be able to drill down and easily produce reports on. We're also going to do some nicer graphs on that. We've got better graphing support there, and we've got a couple people from the community that are helping us explore other graphing models for that. So I can't wait to have that. I think it's going to be a huge improvement, and we really appreciate the NSF funding to produce that. Finally, we're pleased to be able to work more closely with institutions to help them understand the model, complete their assessments, and leverage their results as part of their strategic planning process. This is some of what we're doing with our historically Black colleges and universities and the tribal colleges, is helping them to think about how do you do better research, strategic planning with tools like this, but also thinking about other techniques you've got a lot of folks, especially in smaller programs, who come up either through the research side or through the technology side, and they don't always have the benefit of a lot of leadership training and exposure to principles and practices around strategic planning. So we're just trying to give them some tools there. So I mentioned earlier that we have this range of different institutions using it. And one of the things we learned is that some of the smaller, under-resourced institutions and the newly emerging RCD programs have found the existing capabilities model assessment tool a little overwhelming. It's 150 questions with these different lenses, and it takes a bit of work. In many cases, they say they really like it, but they lack the resources to complete the level of assessment. It's just, they've got a two-person shop, and it's really tough to get the time to do this because they've got to go talk to their libraries and they've talked to all these people to do it. So in response to this community feedback, the Capabilities Model Working Group has started a Focused Tools Committee to better meet the needs of these smaller institutions and emerging RCD programs. So we're working with a number of groups around this to help understand this better. Some of these are regional networks like the Great Plains Network and NJ Edge, as well as others. We're focusing on individual interviews with a lot of smaller institutions that are smaller than the big research groups, but they actually do research. And at this point, our current thinking is to build two new resources. One of them is just sort of a conversation template or script that is, what should you think about when you're first bootstrapping a program? What are the things you might not know about? What are the things you should begin thinking about right away as an approach to supporting research? The next step from that would be for people who say, look, we know we've got issues in these areas and we just want to focus on them. We want to focus on some data areas and then our strategic planning. We want to pick several topics and just assess those. And this has been characterized as a chart your own path model, where they want to see all the questions, but then they say, we're going to focus on these 30 questions this year, and we want to still be able to benchmark on those, but we just can't fill everything out this year. And maybe we'll fill in some of the other questions next year. So that model of sort of chart your own path is one of the things we think is going to be interesting. And as people approached us about this, we heard from some of the big schools, they said, oh, actually, what would be great is we'll do the full assessment this year, and the next year, we'll just do a narrower assessment on the areas we marked as priorities and see how we're doing on those. So a lot of people are going to benefit from some of the new thinking. Anyway, I'm really excited about that work there and hope to have that out soon as well. So that's the end of my prepared material. I'd be happy to answer your questions, hear your comments, or in particular, to talk about how your community might leverage this to understand your common strengths, as well as shared gaps and challenges that you might have. And you can always find out more at the CaRCC.org site or come to any of our groups or activities.